Good morning and welcome to the TC Dojo from Single Sourcing Solutions. The TC Dojo is a TechCom community that is driven by you. Tell us what you want to learn. You choose the topics and we find the experts. In the TC Dojo open session today, we are lucky to have Seth Park as our visiting dojo master. Seth is an information supply chain manager at NXP Semiconductors. He spends his time thinking about how the product development process is a network of information dependencies. He has developed DITA as an exchange standard architecture, allowing developers to contribute to customer documentation in a minimally disruptive manner. He defines and leads his organization with innovative data model initiatives that have increased efficiency and accuracy within the entire information supply chain. I heard about another of his presentations a while ago, and now we are thrilled he agreed to join us in the TC Dojo today. Please be sure to type your questions into the window when you think of them. You don't want to forget what you wanted to ask. Seth will answer them at the next opportune moment. All right, Seth, turning the presentation over to you.
Great. Thanks, Liz.
Show your screen and it's all yours. Perfect.
All right, here we go. So I want to start by talking about my motivation for doing this presentation and most of the conferences that I try to attend and participate in, is I'm really trying to fuel a cultural change around the way we think about documentation quality. And the old perception is what we're trying to get away from, where documentation errors are always seen as documentation problems. And organizations fail to see documentation as part of the quality process. And the result of this is that organizations are missing out on their greatest insight into operational excellence. So what we want to do is have a new perception where we believe that documentation errors result from mishandled information somewhere along the line, not necessarily a documentation error per se. And we also want to move to a place where documentation quality is viewed as a reflection of the internal product development process quality, again, not just of the documentation process itself. And what we get by applying this concept or this worldview to the problem is that organizations can focus on the internal transfer of information for the good of all. So the place that this becomes really obvious is in root cause analysis, which is the subject for this presentation. I put together what I'm calling a durable template for documentation error 5Y analysis. And 5Y is just one of the many root cause analysis tools there are out there. And this is going to apply to almost everything that I've seen in the last 12, 15 years, is that we get some kind of report of an error and it comes in as incorrect information is being shown in documentation, which is a symptom. And then you ask why, it always comes down to some kind of missed information handoff, and that's a problem. And then you dig a little deeper. Why was there a handoff missed? Well, there was some human error at some place. Either there was a misplaced email, a copy-paste error, somebody used the wrong file, something like this. But a human error is almost always to blame at that point. But then you ask, why did that human error happen? And the reason is, for whatever reason, there is no formal method for handling that information, which is one of the causes. And the root cause of all of these problems we have is that there's some fundamental gap in the information flow process itself. And what I want to bring to your attention and really talk about today is what we do with the get well plans. And I'll argue in a moment, if you are not engaged and actively participating in the root cause analysis of errors that present as documentation problems, you're going to end up with get well plans like have better or more reviews in the future, or create an update checklist. And when you do that, you're punting. You're missing the problem. What you need to do with all these opportunities is really push for a systemic solution which will formalize the transfer of information using data standards and institutionalize the transfers within your program management office. So your program management office or your project managers will definitely support you in having document reviews, but you need more help for them to be more in tune with what the real root cause is and make sure that we're really focusing on what those transfers look like. And that network of information dependencies that Liz started with is what I call the information supply chain. And you need one. and here's why. Management doesn't value untraceable systems. If you have a system where you can't trace back the root cause of a document error back to what the root cause really is, which is something that happened long before the documentation flow starts, you're always going to be stuck in this paradigm where documentation errors are documentation problems. And when that's the paradigm that your management uses when they look at you and when that's the way you behave, then the only way to get better is to try to solve a production problem, a production capacity problem. So, more people, more time, more reviews. And that will force your management to believe that this is a matter of resource quantity over quality, and it's going to perpetuate the problem that you have fundamentally, which is that you are disconnected from your business strategy. And management doesn't like to solve these problems because it's just like throwing good money after bad. So the solution basically is to make documentation traceable. And what I mean by that is if you can construct a way of communicating what you're doing and you can actually go do the hard work to make that a reality, then you can really provide a lot more value to your organization and to your customers by proving that documentation errors are actually exposing product development quality issues. And then when you have documentation errors or errors that present as documentation issues, you position yourself as part of the process quality function, and your management will prefer knowledgeable ID staff, information development staff, over an army of fact checkers. And you become a valuable partner in the business strategy by being part of that continuous improvement operation that not only benefits documentation but the product development cycle itself. And as a business partner in strategy, you have a few audiences. Your quality organization needs to understand that documentation errors are actually indications of product development deficiencies, which are serviceable using normal process improvement techniques. And this is really important because if you don't have this mindset, then documentation just seems like this different kind of problem that has intractable problems. But you really need to get in line with the way your quality organization thinks about these problems and making sure that they understand that these are actually serviceable problems that can be dealt with. From a program management perspective, they need to understand that documentation quality provides a critical leading insight into the quality of product development processes. In other words, you can find issues with your product development process and the product being developed much earlier in the process when it's actually cheaper to make changes. If you don't do that when it's cheap to fix, it doesn't get fixed, and then it's a documentation change at the end, opening you up for product quality incidents, scheduled delays, and things like this. And then when it comes down to finding budget and where people are going to prioritize where they spend their money, those people need to understand that the investments that you're going to propose in unifying product development and documentation workflow actually increase efficiency while improving customer success. Excuse me. So let's talk about the cultural revolution. And the next set of slides are about how to turn the battleship. And this is a summary of the points that I'll go through. So no reason to read those here, but if you get the slide deck later, those are summarized for you. So the first thing you have to do is you have to emphasize the importance of the information transactions rather than always looking back at the finished document product as the thing that we're trying to fix. And to do this, you really have to paint a picture that resonates with your organization. And here's the one that I use in mine. Memes are a great way to get right to the point in an entertaining way. NXP has some of the most brilliant engineers in the world. They put out some of the most innovative solutions in the world. But if you go walk by their desk, you can't tell if they're coming up with the next greatest thing or if they're playing Minesweeper. And the reason is they're sitting at a desk clicking and typing on their keyboard because their engineering work is information work, and the product development flow itself is an information workflow. And the term information supply chain is trying to capture the fact that each of us, no matter what we do three fundamental things. We consume some existing information, we do some unique, creative, or novel work, and then the output of what we do is more information which is used for somebody else in their process. And if that is what we do day in and day out, is move information from one person to the next, then there's nothing we can do that will provide more value to our operation than to make sure that each time somebody contributes work to the overall good, that is immediately consumable in the environments for the next person to use. Number two, the quality assurance process is your best friend, not the enemy. And they actually sometimes have budget to fix things. These quality incident reviews is not a time for finger pointing, and it's not a time to be shy. The root cause analysis or a customer quality incident investigation is really the time for you to step up and show that you're a leader and part of the quality team. And the first thing you have to do is speak their language. So this comes from Wikipedia. A root cause is an initiating cause of either a condition or a causal chain that leads to an outcome or an effect of interest. So when you position what you want to do in terms of optimizing your information flow, give it a name like information supply chain, and give it some of the terminology that I've provided here for you. Please take it without attribution. It's for everybody. So I'm saying an information supply chain is a traceable series of information transactions that occur during the product development life cycle, which allows traditional root cause analysis techniques to be used to identify and address sources of errors that would otherwise appear in product endpoints, including but not limited to technical documentation. And the point is, we need to position the work that we're doing as fundamentally addressing quality issues, which in turn will actually improve documentation. And documentation is just one of the endpoints that we're concerned with because, again, we're agents of quality and business excellence. So the third point is that you have to be proactive about the quality risk in your system. And this is kind of scary to some people because they don't want to roll up risk and roll up problems, but it's always okay to do that as long as you actually have a plan for how to address it. Don't take problems without solutions, but certainly sell your solutions by selling the problem. And here's an example of a kind of 5 why analysis that will happen when you're not there. So say you have some kind of documentation where you're documenting a bunch of settings for some piece of hardware, and then each of those settings has a detailed section, and then they get rolled up into a summary table. And let's say that somehow these got out of whack and customer found it. So the problem coming in is that the settings in the summary table were incorrect. And you say, well, why? Well, the change was only done in one place. Well, why was it only done in one place? Because the summary table is manually maintained, and there was a human error, basically. Why? How could this be? It's because the summary table was not auto-compiled. And why is that? Because there is no automated system. Now, the people who do these quality incident reviews, excuse me, are very bright, very thoughtful, and detail-oriented. But if you're not there, they're going to come up with the answer that we need to conduct more reviews and add this problem to the checklist so that it never happens again. And you ask, why in the world would somebody go through the time and detail to do this analysis, get to a root cause, and then punt? And the problem is that we're still stuck in the old perception, which is a documentation error is a documentation problem. Number 4, you roll out your own information supply chain initiative. And this is where you propose how you're going to optimize handoffs and introduce single sourcing into your organization. So for my company, my organization, and our industry as a whole, this is the way that makes I believe, a lot of sense for explaining the information supply chain. First of all, you have product data demand. Like I said, everybody needs information in order to do their work. At the end of their work, they create new information. That new information needs to flow very easily into the next person's queue so that they can do their work and then pass on more information. So this is the network of information dependencies. And then you need to paint your information architecture. And in the backup, I have a detailed slide of this if we have time. But the idea is that there are already many existing data sources in your development workflow. Some of them are spreadsheets. Some of them are header files. No matter what it is, your teams, your development teams, are generating lots and lots of data. But what happens oftentimes is that that information doesn't flow cleanly into the next person's queue, which is why when you paint this picture, you need to label all these arrows of how are you getting this data from one place to the next. And if it doesn't flow cleanly, that's when you work with the content provider to make minor modifications to their workflow in order to generate some content that you can actually use in a more formalized way. And then as soon as you show your information architecture graph, you will probably lose 90% of your audience because it's going to look too complicated. It's going to look like too many moving parts. It's going to look riskier than desktop publishing to some people, which is why you have to immediately follow up with what a data flow automation implementation would look like, how you can actually assemble content using whatever native configuration management principles are in place, and how you can use rules and workflow engines to do the assembly work for you. I found that using continuous integration testing platforms is a good way of doing this. And NXP, we use Bamboo. For a lot of this work, other people use Jenkins. There's other options. Travis CI is a popular one as well. So next, you need to have a basic formula, a formula that can apply to all the different data type problems that you have, a formula that really speaks to the particular issues that your company deals with. In the semiconductor industry, one of the biggest problems that we deal with is reusing blocks. And so a block is basically just a component. So if you think about a printed circuit board or a motherboard, you can think of an advanced network processor as just being a teeny tiny one of those on silicon, but it has all the discrete components and logic components as well. And the problem that we have is that if you want to reuse that source, the traditional way of doing that, like an unstructured FrameMaker, would be to go back to the block source and try to use variables and conditional text to make it behave based on whatever applicability context you have. That starts to fall down really, really fast for a number of reasons. The complexity of the conditional text, the weakness of conditional filtering, and also the fact that it doesn't make a lot of sense from a business perspective, because the job of defining the context of how these blocks will actually be implemented and integrated into a device is a completely different function. So the people who own the block source are very reluctant to make changes whenever new contexts arise, because that makes their source more complex. It doesn't do anything from them except frustrate their own internal verification. And so this is the chart that I use. Yours would be different for whatever your industry is, but the little gears sort of in the middle right is where the fun parts start. So even as soon as you get a device-specific output, a device-specific rendering of the stable block source, you still have to render that into the different consumer-specific packages that you need. And I know that's a little bit vague, but as an example, our product and test team has basically a big spreadsheet that it contains the same information that's in our tech docs, which is the same that goes into our our customer enablement tools, like that one shown there, QCVS. but you need to be able to find a way to generate all those different views from the same set of rendered context-specific output. And when you do that, you know that the outputs that you're getting are all aligned because they come from the same source. And if you do it right, you have built-in traceability where through metadata or some other way, in the output you have the information you need to trace back from the rendered device-specific output that it came from, and then from there you can trace back all the way to the stable block source. Again, your strategy is going to be different based on what your main problems are, but these are the ones that we were solving in semiconductor. Next, you need to talk about how you're going to deal with complexity, because you can't escape complexity. You can move it around all you want, but you have to deal with it somewhere. I will argue that the earlier in the workflow you deal with it, the better off you are. And there are going to be, many of your developers are going to find the, really good ways of coming up with the design or the product development artifacts that they're responsible for and checking into their design repository. So that's what I'm showing here is the back-end process. Let your development team be free to figure out the best way to do that. And then partner with them to figure out how to get from there into Ditto. And what that does is it collapses the complexity way back where it's easy to address, where the experts are really sitting. And then once you get to simple data, you can do an import or export into your CCMS, and then from there that content can live as read-only source for documentation services. And by doing this, you set up a real clean delineation between where you're allowing your organization to focus on differentiation, that is coming up with proprietary means if necessary to use the right tool for the job, and then handing over using DITA as an exchange format to leverage standards and off-the-shelf solutions. And when you do that, that greatly reduces the cost of your DITA CCMS implementation because it's just dealing with, like I said, simple DITA. And you don't become so dependent upon your DITA CCMS when you use it in this way, because you're not building in business intelligence into the DITA CCMS. You're simply using it as a publication management environment, which is really where it shines. And showing this also helps to explain why we can't use a one-size-fits-all solution. And all one-size-fits-all solutions end up being one-size-fits-none. So when you talk about using DITA as an exchange format, the next battle you have is explaining how that doesn't increase the complexity of the publication piece because of the magic of DITA. You do need a way of painting the picture of if you've got all these different workflows contributing content, then how do you keep them aligned? How do you keep them synced with your bill of materials manager? And how do they integrate into publications? And all this can be done, and here's an example of how I communicate that at the highest level in NXP. Again, the point is to unleash the market of innovation to allow experts to find the best way possible, and simply say, if you work with me to get DITA out of your flow, then you never have to write documentation again, at least not for those data types that fall into this flow. And point number 5 is go to the Gemba and make an offer they can't refuse. And this is all about finding ways to integrate with existing flows and not trying to recreate flows and not telling them that, okay, thanks for everything you've been doing to get this product out the door. Now I need you to come use our DITA CCMS to write your documentation. So Gemba, I love this term. I learned it in Six Sigma training. It's a Japanese term meaning the real place. It's where the value is created. It's where you can really observe what's going on. It's the best place for you to implement improvement ideas. and it's where you have to go to really see the impact of the full problem. And if you're a Ralph Ellison fan, you might remember when the protagonist goes to the Liberty Paint factory and goes down to the basement and meets Brocker, and Brocker tells him, down here is where the paint is made. So to me, finding the Gemba means finding where the paint is made in your organization. And for me, it was very coincidental that those people were literally in the basement, and they were literally invisible in a lot of ways, mostly because they needed a quiet, dark place where they could quietly assemble all of the non-structured rogue data being thrown at them, trying to figure out what's changed between different document revisions, trying to shore up what's being told by marketing and against what they're actually seeing in the technical documentation. And those people, the product and test engineers in my organization, know what's going on better than anybody because they get all the junk and they have to sort through it all the time. So those are the people that I go to whenever I have questions about data flow and when I want to work with them to figure out how to get documentation out the door. So here's a sample. Here's one way that my team worked with product and test to solve some of these problems. So pin information is really important to semiconductor products. It's the way that the chip interacts with the outside world. It's what gets set down on the printed circuit boards of whatever application it's going into. And we looked at the way pin information was being handled. And you can see by all these arrows, there were many instances of copy, paste, reuse. And every single one of these instances basically represents an area of defect opportunity, places where things can go wrong. And they were going wrong. So there were some cases where we were showing pin information in a document using a pin name that didn't match other ways that we deliver pin information. And when we looked at this, and by the way, NXP has an exceptional quality record, and we were able to deal with all these issues, but it took a lot of manual work and a lot of wasted time to make it work. So the question is, how do we recover that effort and apply that towards making new things instead of constantly reviewing old things? And if you looked at this and said, yeah, we really need more document reviews and better checklist, then you are complacent in an elaborate cover-up. And so here is the afterflow that we put in place. Now notice we do have multiple input sources, and that's going to happen a lot. You know, one of the reasons on the left there was so much copy-paste reformat is that there is nobody who needs the entire unified model for what they do. You know, for instance, when you're generating IBIS models or ORCAD symbols, these hardware definition files, you don't need, you know, rich information about what that signal does or how to use it. In documentation, you don't need to have, you know, detailed hardware information about those signals. So the problem basically is that you can't get to a single source very easily whenever you have so many people who just need proper subsets of the information. Sometimes you can get there, not always though. In the case of the pin information, we were able to get there with two input sources. And those two input sources did have a little bit of overlap, and that overlap was actually really important because it allowed us to make associations between the two different files. So specifically, like a primary pin name would be in one of the files that had 80% of the information, but that primary pin information or name would also be in the other file, which covered the other 20% of the data we needed for a completely unified model. And that really served two focuses. You know, first we needed it to do the data binding. The second piece was we were able to detect the issues that were causing us headache much, much earlier because we were using a processing technique to use that primary pin name to do the data binding. And if the primary pin name was not the same in both of those files, then we got an error very early on and were able to fix them before customers started using it, before we started doing board layout and those kinds of things. So just the fact that we required consistency in order to use the automated flow helped us several times to prevent some much more costly mistakes. One point I'll make quickly is that this, on the right, this term origin, that's actually an open source project, origin-stk.org. When I said that I went down to the basement to find out where the paint was made, we decided that we should be making our documentation in the same paint factory. So Origin is the platform, the Ruby-based platform that product and test engineering uses. So we wrote our data generator in the same language, using the same infrastructure they were using, so that we were using the exact same Ruby models that product and test was testing. And really the summary here again is I have docs as one of the output there at the top, but there were many outputs. When I have these readouts and talk to other parts of the organization, I like to diminish the emphasis on the documentation output as just one of the many outputs and just one of the many problems that we're solving. And now people in the organization aren't asking me why a guy from documentation is in the room anymore, because they know that I'm one of their strategy partners looking out for everybody's good, not just trying to find a cheaper way to get documentation out the door. And then when you can actually come up with some automation, when you can reuse the exact same data models as your test organization, you get the clear and obvious benefits of automation. I like to lead with the strategy argument and the entire ecosystem quality improvement piece, but there is a time and a place to talk about how we're adding efficiency to the documentation process. So here's one example of how that PIN data project has really helped us out. There's 92 pages of tables and 5 very detailed ball grid diagrams generated from the exact same source. So nobody's writing these, nobody's double checking them, and you can imagine how tedious it would be to sit down and draw these drawings by hand and try to cross-check them with the tables like we used to be, or used to have to do. So, I mean, that's our option A, is to fix the data flow problem. And when the design changes, we can update the documentation within minutes. We have the same updates that product and test has, and when they flag issues in product and test, we have a way of tracing exactly where in documentation that error or that data shows up that may be a problem. And of course, the other option was to hire an army of low-cost labor to create and maintain these docs and try to keep them all in sync. So that table that you see on the left, we actually show that table twice, once by signal name and then once by bus name. And so keeping all of that in line is a huge headache, especially when you have 1,932 pins muxed across many signals. It would be a nightmare to do by hand. The other thing that this provides is that during document reviews, nobody has to check these tables or these images anymore. We certified the process that generates them. We do random sampling tests, but we have very high confidence in the algorithm that generates these things, mainly because they're using a lot of the same routines that are used by test engineering to test it. So basically, test engineering is doing a documentation review for us without actually reading the document. And so that's one part of our hardware spec, or our data sheet as we call it. And once you get to this point, you can create a diagram kind of like this, where you show the table of content showing where the different content is being sourced from, and use this as a roadmap. You see we still have about 17% of the data sheet is not yet using what I would call an automated single source flow. We're working through those, but we got 83% done pretty quickly with 2 major projects, one around the hardware specs and one with the pin data I've been talking about today. and PowerPoint crashed. Hold on.
Wow, that's all right. We've got a question, it looks
Okay.
like. While you are... Oh, no, you're back. Do you want to answer the question, or do you want to continue?
Let me see. This will actually continue. Okay, yes, let's do the question.
How automated do you get in your information flow into your CCMS? Are you allowing dev and others to import the data directly, or do you get a data project that you import for writers? Suggestions, pros, cons of either approach? It's a complicated question.
No, it's a great question. So in my business, we have a strong notion of a bill of materials. So the bill of materials is managed by a product lifecycle management tool, which basically stores the metadata about products. So I like to think that we're as automated as we can be. So basically what we do is we use that bill of materials manager to populate a workspace on a Linux server, so that we're using the exact same mechanism that our product development team uses to build their work areas, to build this staging work area, making sure that we're using the same labels and all that stuff. And so what happens is by the fact that we're using the exact same bill of materials tag, we're guaranteed to pull the right files, or at least the files that were tagged appropriately. And then that gets pushed with a couple clicks to the data CCMS. And then once it gets there, it has, since we're using data for that, we have several data elements that hold the metadata about where the source file came from, what parameter overrides were used, and then some other really important information like the name of the bill of materials that was used, and also the versions of all the tools that were used to generate that output, because that's also a traceability aspect we have to account for. And I guess the second part of that question is, in order to participate in this workflow, then you have to work in the engineering environment that the development team is using. And I'm feeling a bit remiss for not putting another slide in here. I talked about this as a culture change, because none of the processing that I've talked about is difficult. It all makes a lot of common sense, and anybody could have drawn it. But I guess the real beauty and the real magic of all this is using these kinds of conversations and methodologies to get the political capital to actually go to the development environment, the developer team, and get them to allow you, if you will, to work directly in the same files that they're working on in a lot of cases. And so there's a interesting political thing that happens when you do that, because the first reaction is for them to say, no, I don't trust documentation people in my files. And then you basically have to say, well, then if we can't work on your files, then whatever you put in the system is going to go directly to customers. And if there's documentation quality issues that come out against it, then we're going to have to make sure that you go implement those changes. And then after a while, if your political capital works and you've gained some trust, you actually get that relationship smoothed out to the point where they will allow you to work on the files directly, because first of all, they don't want to do that work, and second of all, they start to begin to trust that you're going to do the right thing. And for people using good source control systems and configuration management techniques, this should not present a problem, because that's what those two disciplines are exist to protect against. I think somebody mentioned, the question mentioned dev versus master branch or something like this. Yeah, you leverage those exact same processes and you make the commit, and in some parts of the organization we insist that the person who technically owns the files is the person that does the tagging, so it's their way of signing off on the changes. And it's a way of signing off that's actually integrated with the processes that they already have. And it means that if they're signing off on these processes one at a time, and they know that we're using the same configuration management techniques, then when it comes time to review the reference manual, they don't really have to do it, because they've reviewed every single change along the way, right, one at a time. So that gets a lot of the subject matter experts into more of a real-time proactive contributor to the documentation process, rather than expecting them to put down everything they're doing and take 2 weeks out to review a 5,000-page reference manual, which never happens.
All right.
And actually, this is a, go ahead. Was there another question?
No, I was just going to say, he says, yes, thank you for the information.
Okay, good. So what I'm showing right now is a typical semiconductor information architecture, and I said it was in backup, but it's here. And so this is, like I said a little bit earlier, this is one way that I use to show the real key intersection points that we have to have. It's showing that we have pin information, register information, and then the hardware spec information. And we have a lot of existing inputs, which are in the center column, and how they flow into those different processes, and what those processes output in terms of our documentation set. There's lots of other outputs, absolutely, but when you want to answer the question, you know, where is the content coming from, and that's what you're going to have to do as soon as you start doing some kind of root cause analysis. This is where you can start to do your backtracking to figure out, you know, if we got a problem in a pin list, then that's the ISC pins flow, and there are multiple inputs to that. And then if that flow is not working, then we know exactly where to focus. And I did speak quite quickly, so I'm hoping there's more questions, and I'm not sure if you had a different landing page you listed on this.
Oh, that looks great. So here's a chance to type in your questions. I know that there's a lot of information there. Thank you, Seth. That was actually, that's really quite brilliant, I have to say. Not everyone has taken that approach, and I think in years of going to conferences, you don't really see this one. And I think it's genius. Type in your questions. Let me tell you what's coming up. Our next mastermind session is October 18th. The mastermind is a monthly member-driven discussion group where attendees present their specific challenges on the topics on their mind in a confidential, supportive environment. We have two going on right now. One is everything TechCom, DITA to TBA, to specifics of cross-references and graphic layout. The other is focused on Arbor Text and Windchill. It's a collaborative peer-to-peer environment where everyone lends their experience to each other. Our upcoming topic is actually show and tell. Everybody's going to talk about their teams, their skills, their tools, and their processes. You can sign up at the website. Next month, we're having Kit Brown-Hoekstra, former STC president, talking about editing the work of non-native English speakers. It's going to be a great session, so be sure to sign up. How do you do that? Well, just go to tcdojo.org, and you'll see the sessions at the bottom of the page. Last thing I'll mention is if you are local to the Bay Area or semi-local and can get here on a weekend, we're doing TC Camp 2017. This is our 5th year in Santa Clara at the end of January between playoffs and Super Bowl, so no excuse not to come. All right, let's see if we've got some more questions. All right. There's a lot of vocabulary here, and I heard you say Six Sigma. Where can someone get started learning so they speak the right language?
That's a really good question. I think every organization is going to have a slightly different root cause analysis tool, but they all have one. So you can definitely do some Wikipedia work on root cause analysis, statistical process control, those kinds of things that come out of Six Sigma. But I really think your best resource is to find the people in the quality organization who are already doing these. Familiarize yourself with the template and get involved with some of the CQI investigations, the customer quality incident investigations. It's a whole discipline, it's a whole culture. You know, quality people don't get any love, so if you if you show some affection to somebody in quality, they will take you under their wing and help you do anything you want to do. As far as like internal networking goes, I mean, there's some networking advice. There are some people that you absolutely have to have those close relationships with. And I think quality is probably one of the most important, along with finance.
It definitely seems like this is a bigger deal than it sounds like. This is bigger than it seems, I think.
Yeah, I mean, it's 10 years or more of intense, negotiating. Like I said, when we first started this process, we were using unstructured FrameMaker, and the design team had their own repository of these FrameMaker files, and they wouldn't even let us have read access into them. They were two very, very different silos. And so it really took many years of working directly at the senior vice president level even for R&D to get them to understand that we will never get on top of the documentation problems we have, and we're never going to be able to move the bar in terms of efficiency of block reuse until we think about what we do as a series of informational transfers. And sometimes you get lucky, sometimes you don't. These are the kinds of things that I feel like it's your responsibility, it's our responsibility to make sure you have these plans and these visions on the table. During a downturn is not the best time to go talk about VPs, but when there is any time and when there is annual budget planning is the time for you to say, we've had these long-standing intractable problems, which means we're going to have to do something fundamentally different. And here's a paradigm shift, a mind set, a worldview that actually lets us look at the real problems and not try to catch them way too late in the process. And I think the messaging about it helps us fix the problems when it's cheap to fix them is something that resonates a lot, especially with the people who are in charge of P&L. Because it's the absolute truth. If the later you capture these issues, the later you try to deal with that complexity, the more and more expensive it is, almost exponentially so.
All right, and we have another one. Are you doing any automating reporting in your information process to calm the concerns of the checklist lovers? Any recommendations in terms of showing or reporting audits in your information flow?
I love this question. It's something I've not been totally successful at yet. But I'll add some other slides to the backup when I post this, but absolutely. I told you earlier that continuous integration platforms make really good automation tools, but they also happen to be pretty good at continuous integration too. So the place that I want to be is completely end-to-end, where we have requirements traceability systems that hold our actual testable requirements so that we can, after we do a bill of materials release, we can generate what we need and then go run those tests automatically against the content. And so that would give us, answer the question of are you meeting your requirements? It's really, really easy for somebody to go to a checklist and say, yes, the document's done. But that doesn't answer the question that the information supply chain answers. The information supply chain answers, is this information ready to be used by the next person in the workflow? That's a much different question. And so you have the opportunity to let the consumers of the information set the rules. There's a different slide set I have that talks about the difference between a producer-dominated system and a consumer-dominated system. And if you move the bar to, and we've all seen this, right? We get stuff thrown over the wall. That's the producer-dominated model. But if you have a system where somebody can write electronically testable rules about the quality and completeness of the content you need in order to do your job, then you're in a consumer-dominated model where people are trying to satisfy your requirements and not just throwing you whatever they have available and expecting you to make do with it. And that mindset isn't about getting even with the people that have given us junk all these years. It's really about the end-to-end operational efficiency. And when it comes down to it, the answer, it does take more upfront effort. It is harder to do structured content development than unstructured content development. But the benefits that you get by doing the upfront piece accrue throughout the organization for the life cycle of the project. If you don't do it then, it becomes costly, hidden expense that you sort of never can really get your hands around. And a lot of times that's almost our own fault in the technical documentation or technical content development arena, because we really love to please, and if we get junk, we sometimes maybe too happily take that junk and deal with it. And I think we're doing a disservice to the organization by not trying to shine a bigger light on the fact that we're staying up nights and weekends to get this stuff out the door. And speaking of out the door, the other problem with that is this kind of work is so unstructured and difficult, if not impossible, to train on, that when you have these people who are complicit in these elaborate cover-ups of process problems walk out the door, so does all of your quality, because the problems that they were covering up are not going to be covered up against until they rear their ugly head, and whoever is filling in for them or replacing them down the road develops the same kind of instinct for sniffing out these issues and resolving them in a creative way, or fixing it the right way.
That is huge, actually. All right. Well, we've gone a little bit long, and we had some really great discussion, and I appreciate, Seth, for you to come in and doing this at all. I think this is a huge topic, and not one, kind of an innovative one, actually, for TechCom staff to take. I expect to see more conversation about this in the future.
Good. It was a pleasure. Thank you.
All right. Thanks, everybody, and we'll see you next time.